With standard form, we see the third way to write a linear equation. Now, unlike the other two, you can't look at the name and know automatically what the key characteristics are. But as you're going to see, standard form is useful for finding your x and your y intercepts. So our target is that we will graph linear equations using intercepts, and then we will write those linear equations in standard form. So here is standard form. Again, write it big, put a big box around it in your notes so that you can commit this equation to memory. It is ax plus by equals c. As in the other forms, the x and the y stay x and y. A, b, and c, they are all integers, positive or negative whole numbers. No fractions, no decimals up in there, which is awesome for many of you. So an example of this would be something like 3x plus 4y equals 24. That would be a linear equation written in standard form. So let's find some x and some y intercepts. If you think about those intercepts, and I put this graph up here just to give you a visual. If I were to draw an intercept on here, let's say I put it right here. Well, just kidding. There we go. Okay, that is crossing the x-axis at -2. The x value is -2. The y value is 0. Or if I had one right here, that would be +4, 0. The x-intercepts always have a y value of 0. And then kind of the opposite for that, y-intercepts are always going to have an x value of 0. So like here would be 0, 2. Here would be 0, -4. So keep that in mind. So first, to find the x-intercept, you're going to substitute y for 0 and then solve for x. So all that business we did with literal equations and solving for certain variables, it really did have a purpose to it. So 3x plus 4 times 0 equals 24. And then we're going to solve for 4. I'm sorry, not for 4, for x. We're going to isolate it. So 4 times 0 is going to cancel. I'm going to go ahead and cross that out. So what I'm dealing with then is 3x equals 24. And you can see that in your head already that x equals 8. So that intercept is going to be 8, 0. And then step 2, find the y-intercept. So do the same thing, but this time we're going to substitute 0 for x this time. So 3 times 0 plus 4y equals 24. So 3 times 0 is going to cancel because that makes it 0. 4y equals 24. You've already solved that in your head. Y equals 6. So the y-intercept is 0, 6. That's what that coordinate is. Next, we're going to graph a line using those intercepts. So here's a different equation. 2x plus 5y equals 20. So we're going to find those intercepts. So the same thing of what we did before. And something that you notice is like, okay, I'm just going to drop that 4y term because I'm just going to have a 3x. So 3x equals 24. And you'll start to see that more clearly the more that you do. So first I'm going to substitute. I'm going to find the y-intercept first. How about that? 2 times 0 plus 5y equals 20. So that's going to come down to be 5y equals 20. Y equals 4. So that is a coordinate of 0, 4. And then to find the other intercept, 2x plus 5 times 0 equals 20. So that comes down to be 2x equals 20. So x equals 10. And then that coordinate would be 10, 0. Then step 2, graph those intercepts. So first 0, 4, 0, 1, 2, 3, 4. And then 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've graphed those two intercepts, and I really only need 2 points at a bare minimum to graph a line. So I connect the dots, and I don't just connect them, but extend past those. Like so. There you go. We'll put our arrows at the end. And there is our graph of 2x plus 5y equals 20. We graph that using intercepts. That's the benefit of standard form. When you have horizontal and you have vertical number lines, you look at them and you're like, whoa, something's not right with that. If it just says x equals 3, like what am I supposed to do? What that communicates is that for any value of y, it doesn't matter what I put in for y, x is going to equal 3. So no matter what y is, x is 3. So that is going to look like this. Something like that. No matter what x is, no matter what y is, x is always 3. So the way that I keep this straight in my mind is if I see x equals 3, it's crossing the x-axis at 3. Now, kind of in the same fashion, if y equals negative 4, what that communicates is that for all values of x, no matter what x is, y is always going to be landing on negative 4. 1, 2, 3, 4. Could be like here. Could be over here. So that's what that line would look like. It's crossing the y-axis at negative 4. And then finally, we're going to transform to standard form. So here is an equation. We're going to write that in standard form. Now, if you think about standard form, it first of all didn't have any fractions. I'm going to have to distribute that, and then I'm going to have to move things around so that my x and my y terms are on the same side of the equation. So first step is cleaning up the equation. And by cleaning it up, you know that to mean doing the distributive property where necessary, and then also we're going to be clearing out those fractions because standard form has to be written with integers, no fractions, no decimals. So I'm going to start by distributing that negative 1/3 to each of those terms. So on the left side, y minus 2 stays there. And I'm going to have negative 1/3 x. And negative 1/3 times 6 would be negative 6/3, which would be negative 2. So needing to get rid of that fraction over there, I can multiply by the whole number 3. That's the reciprocal of it. And so that would end up being 3/3, which is 1. So I'm going to multiply both sides by the whole number 3, and then I'm going to be distributing that back over there. Right? Yeah, okay. So y minus 2 equals negative x, because that would end up being negative 3/3. I'll come over here and show this to you. Negative 1/3 times 3/1, because that's what the whole number 3 would be. Would end up being negative 3/3, which is negative 1. And then 3 times negative 2 would be negative 6. So I did not go back to what I started with. What I did is it ends up changing to a negative because that was positive 6 and now it's negative 6. Next step, move the terms. I want the x and the y terms to be on one side, and then my constant term is going to be on the other side. So what I have is y minus 2 equals negative x plus 6. I'm going to undo this negative x. I'm going to move it over there by adding x to both sides. So as I clean that up, then I would have x plus y minus 2 equals negative 6. I need that constant term on the other side, so I'm going to undo subtracting 2 by adding 2 to both sides. Cancels there. X plus y equals negative 4. And that, my friends, is in standard form. You've seen this poster on my wall. This is showing those 3 forms of linear equations. So you have 3 equations, you have 3 different purposes. As we talked about in each of those lessons, standard form, like what we're doing now, is useful for when you are wanting to find those intercepts, if you're wanting to graph using that. Slope-intercept form, that's what you've got if you've been given the slope and you've been given the y-intercept. Point-slope form is when you have a point and you have the slope. And x of 1, y of 1 is that point. To kind of sum all this up, you can describe any line using one or more of these forms of a linear equation. So y equals negative 2/3 x plus 6, that describes this line. So does y minus 4 equals negative 2/3 times x minus 3. So does 2x plus 3y equals 18. All three of those equations are describing the same line. Those are equivalent equations. Any two equations for the same line are equivalent. So pretty nifty there. 3 different ways to show one line.